Hello my dear friends and welcome to our today's class. It's our fifth lesson on the fifth topic of Form 3 work, which is called Current Electricity 2. As usual, let me comment by giving the quote of the day, which states that never let the thought of failure stop you from pursuing your dreams. We shall discuss that quote at the end of our class today. So today we are looking at resistor connections, so resistor networks. So basically we shall be looking at ways in which we can connect resistors. So we have two ways. One, we have series connection of resistors, and two, we have parallel connection of resistors. So that is resistors connected in series. So resistors are said to be connected in series when they are connected end to end. That is as shown in this particular diagram. So whenever you connect resistors along each other, then we say that they are in series connection. So you can see our first resistor R1 connected along our second resistor R2, connected along our third resistor R3. So whenever resistors are connected in series, the same amount of current flows through each resistor. And that simply means that the total current, that is the I total, the total current from the source, must be equal to the current through the first resistor, which is I1, must be equal to the current through the second resistor, which is I2, must be equal to the current through the third resistor, which is I3. So for any series connection of resistors, total current, that is I total, must be equal to I1, must be equal to I2, must be equal to I3, depending with the number of resistors that you are connecting. For example, if we had 4 resistors in this particular diagram connected in series, the equation would be I total, that is the current through the source, must be equal to current through the first resistor, that is R1, must be equal to the current through the second resistor R2, must be equal to the current through the third resistor I3, must be equal to the current through the fourth resistor, that is if it was there, that is I4. So this is the most important point to note, that whenever for any series connection of resistors, the total current or the current through the source must be equal to the current across each and every resistor in that series connection. Then also for series connection, the potential difference across each resistor is usually different. So that simply means that if you want to find the total voltage or the voltage across the source, you simply take the sum of the voltage drops across each of the resistors that are connected in series. So if this was V total, that is the voltage across the source, must be equal to the sum of the voltage drop across the first resistor plus the voltage drop across the second resistor plus the voltage drop across the third resistor. Therefore, V total for series connection of resistors must be equal to V1 plus V2 plus V3. Then also from Ohm's law, we did so that voltage and resistance, that is must be directly proportional to each other, or the voltage and also the current. So from Ohm's law, we saw that V is equals to IR, that is potential difference, is equals to the product of the current I and the resistance through that particular material. So from this particular equation, we can simply rewrite our equation, that is for V total. So V total shall be given by I total times R total. So from this equation here in pink shall be rewritten as, that is V total will be I total times R total, that is I times R total, must be equal to V1. V1 shall be given by I1 times R1. V2 shall be given by I2 times R2. Then V3 shall be given by I3 times R3. So from Ohm's law, we can see that I total I1 R, that is I total R total, must be equal to I1 R1 plus I2 R2 plus I3 R3. Then since for series connection, you have seen that I total, that is the total current, is equals to the current drop across each of the resistors. Therefore, it means that I total is equals to I1 is equals to I2 is equals to I3. Therefore, because I1 is equals to I2 is equals to I3 is equals to, that is I2, it simply means we can divide each and every term by I total, because after all, I total is equals to I1 is equals to I2. Therefore, if I divide each and every term of this particular equation by I total, I'll simply remain with, that is I total will divide with I total, I1 will divide with I total, because I1 is also equals to I total. Then I2, that is I2 will divide with I total, therefore they'll cancel out. Then I3 will also divide with I total, hence they cancel out. So this equation can be rewritten as R total is equals to I1 plus, that is R1 plus R2 plus R3, because the current is the same. Therefore, I've divided each and every term by I total. So if I total cancels with the current through I1, I2, and I3, this equation shall remain as R total is equals to R1 plus R2 plus R3, the way I've indicated here. So for any two or three, for any three resistors which are connected in series, their total resistance shall be equal to the sum of the resistance of each and every volt, that is each and every resistor within that particular connection. Therefore, if we want R total for three resistors, we simply take resistance through the first resistor plus the second resistor plus resistance through the third resistor. If we had maybe 4 resistors, R total will be R1 plus R2 plus R3 plus R4. So in connection to that, let's look at an example to help us conceptualize that formula. So the question reads that the figure below shows 3 resistors in series connected to a power source. So a current of 2 amperes flows through the circuit. So in short, this is I total, or the current from the source. So we are required to calculate part A, the voltage drop across each resistor, the voltage drop across each resistor. And we know that for any series connection of resistors, total current, or I total, is equals to the current through the current drop across each component. Therefore, if this is the I total, that is the 2 amperes, it means also the current through the 2 ohm resistor is 2 amperes, the current through the 6 ohm resistor is also 2 amperes, the current through the 8 ohm resistor is also 2 amperes. Then if we want voltage from Ohm's law, we saw that voltage can be given by the product of the current and the resistance. Therefore, if we want the voltage across the 2 ohm resistor, we simply take the product of the current across the 2 ohm resistor and the resistance across the 2 ohm resistor. Therefore, voltage through 2 ohm resistor, we'll simply take I through the 2 ohm resistor times R through the 2 ohm resistor. And we have said that because these resistors are connected along each other, or they are in series with each other, it simply means the current flowing through each component is equal to the total current, which is the 2 amperes. Therefore, the total current through the 2 ohm resistor is simply the I total from this particular equation here, which is 2 amperes, then times the resistance through the 2 ohm resistor, of course, is just 2 ohms. Therefore, 2 by 2, we shall obtain 4 volts as our voltage across the 2 ohm resistor. Next, we move to voltage across the 6 ohm resistor. The same formula, voltage V is equals to IR. Therefore, voltage through the 6 ohm resistor, we simply take the product of the current through the 6 ohm resistor and the resistance through the 6 ohm resistor. So because again this is series connection, I total is equals to I1, I2 plus I3. So the current through the 6 ohm resistor again is also 2 amperes. Therefore, we take the current, which is 2 amperes, times the resistance through the 6 ohm resistor, which is 6 ohms. Therefore, 2 times 6, you'll obtain 12 volts. Then we also look at the voltage across our last resistor, which is the 8 ohm resistor. Again, from V is equals to IR, voltage through the 8 ohm resistor shall be the product of the I, the current through the 8 ohm resistor, which is equals to I total, which is 2 amperes, times the resistance through the 8 ohm resistor. Therefore, the current is 2 amperes times 8, which gives us 16 volts. Part B, they want us to find the voltage across the source, the voltage across the source. So the easier way of finding that, we simply sum the voltage drops across the 2 ohm resistor, 6 ohm resistor, and 8 ohm resistor. Because remember we said up here that whenever resistors are connected in series with each other, then V total, or the total potential difference, shall be given by the summation of the voltage drop across each of the components. So because we have 3 components here, that is the 2 ohm resistor, 6 and 8 ohm resistor, therefore the sum of the voltage drops across these 3 resistors must give us the V total, or the voltage across the battery or the source. Therefore, voltage across the source shall be given by V1 plus V2 plus V3, where V1 is the voltage through the 2 ohm resistor, V2 is the voltage through the 6 ohm resistor, and V3 is the voltage across the 8 ohm resistor. Therefore, we'll simply take 4 volts plus 12 volts plus 16 volts. So if you take that sum, you will simply obtain 32 volts. So that is the voltage across this particular battery or the source. Then the last question, they want us to find the total resistance in the circuit, the total resistance in the circuit. So again, we said that we have derived up here that the total resistance through the circuit for any series connection shall be given by the summation of the resistance through each and every component. So because we have 3 components, that is the 2 ohm resistor, 6 and 8, therefore R total shall be given by R1 plus R2 plus R3, where R1 is the resistance through the first resistor, R2 is the 6 ohm resistor, and R3 is the 8 ohm resistor. Therefore we simply add, so R total shall be 2 plus 6 plus 8 ohm, which gives us a total of 16 ohm. So that is the total resistance through the circuit, the total resistance through the circuit. Sometimes we can use the word effective resistance or equivalent resistance. Next, we look at the second part, which is a connection of resistors in parallel. So resistors are said to be connected in parallel whenever they are connected side by side, as shown in this particular diagram. So this is what we call parallel connection of resistors. That is, resistors are connected side by side. So you can see R1 is connected on the lower side of R2, R2 is connected on the lower, that is R3 is connected on the lower side of R2. So this is the parallel connection of resistors. Then whenever resistors are connected in parallel, the current flowing through each resistor is different. So that one simply means if you want to find I total, that is the current through the source, you simply take the summation of the current through each of the components. Therefore, if we want I total, we'll take the summation of the current through R1 plus current through R2 plus current through R3. So for parallel connection of resistors, I total is equals to I1 plus I2 plus I3. Then the potential difference across each resistor is equal. So is equal to that of the source. Even in Form 1, under cells and simple circuits, you did say that whenever the cells are connected in parallel, then their EMF or the total potential difference shall be equal to the potential difference across each component. So for parallel connection of resistors, V total must be equal to V1 is equals to V2 is equals to V3. Therefore, the V total here, or the voltage across the source, is equals to the voltage through R3 is equals to voltage through R2 is equals to the voltage 3 through R1. That is for any parallel connection. Therefore, V total is equals to V1 is equals to V2 is equals to V3. Then from Ohm's law, we saw that V is equals to IR. That is potential difference is equals to the product of the current and the resistance. From here, we can make current subject of the formula simply by dividing both sides by R. Therefore, we shall have I is equals to voltage over resistance. Hence, the equation of I total, remember I total was I1 plus I2 plus I3. So this equation of I total shall become, so I total will simply be V total over R total, because we have seen that I is equals to V over R. So I total will be V total over R total. So V total over R total, then plus I1 will simply be V1 over R1. So V1 over R1, then I2 shall be V2 over R2. So V2 over R2, then I3 shall be given by V3 over R3. But since for parallel connection, V total is equals to V1 is equals to V2 is equals to V3, because we have said that for parallel connection, potential difference across each resistor is equals to that of the source. So this one simply means that if V total is equals to V1 is equals to V2 is equals to V3, it simply follows that we can divide these each and every term by V total. So V total over R total, V total and V total will cancel out, so that we just remain with 1 over R total. Hence, we have 1 over R total here. Then again, if I also divide this term by V total, remember V total is equals to V1. Therefore, they will just cancel out. So I'll remain with 1 over R1. 1 over R1 plus V total, that is V2 over R2. If I divide this term again by V total will cancel with V2, because after all, they are equal or they are the same. Therefore, I remain with 1 over R2. Then V3 over R3, again, if I divide it by V total, because V total is equals to V3, so V total will cancel with V3, so that I just remain with 1 over R3. Therefore, this is the formula that we use to find the effective or the total or the equivalent resistance for resistors which are connected in parallel, such as the ones shown up here. Therefore, we can also show that for any two resistors, 1 over R total is equals to 1 over R1 plus 1 over R2. Remember, if you are dealing with maybe 5 resistors, it will be, the formula will become 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. So for any two resistors which are arranged or connected in parallel, 1 over R total will be 1 over R1 plus 1 over R2. If I find the LCM on the right hand side, the LCM is simply R1, R2. Therefore, R1 goes into R1, R2, R2 times. That is, R1 will cancel with R1, so that I just remain with R2. Then R2 goes into R1, R2, R1 times, because R2 will cancel with R2, so that I just remain with R1. So if I pick the first part and the last part here, I'll have 1 over R total being equal to R1 plus R2, which is just the same as that is R2 plus R1, which is just the same as R1 plus R2, because we know that sum is usually commutative. That is, we can just change the position without changing the total value of the equation. Then over R1, R2. Then if I take reciprocals on both sides, I'll have R total over 1, which is just R total, being equal to R1, R2 over R1 plus R2. So you just take reciprocals on both sides of this equation. Alternatively, you can also cross multiply, then make R total subject of the formula. So you'll end up with R total being equal to R1, R2 over R1 plus R2. So this one simply shows that for any two resistors connected in parallel, their effective or their total resistance can be given by the product of the two resistors divided by the sum of the resistance of the two resistors. Then I have an example here. So the example reads that the circuit below shows 4 resistors connected across a 3-volt supply. We are required to calculate the effective resistance. Remember, effective simply means total resistance or equivalent resistance. So because here we have 1, 2, 3, 4 resistors, it means 1 over R effective will be 1 over the first resistor plus 1 over R2 plus 1 over R3 plus 1 over R4. So we are using this formula because we can see the resistors are connected side by side or across each other, or they are in parallel. Then we have said that for any parallel connection for resistors, then 1 over R total shall be given by 1 over R1 plus 1 over R2 plus 1 over R3. Therefore, 1 over R effective shall be 1 over the resistance through the 2 ohm resistor plus the reciprocal of the resistance through the 6 ohm resistor plus resistance of the resistance, that is the reciprocal of the resistance through the 8 ohm resistor plus resistance of the resistor, that is through the 10 ohm resistor. Therefore, 1 over R effective is equals to 1 over 2 ohm, that is resistance of the first resistor, plus 1 over 6 ohm, which is the resistance of the second resistor, plus 1 over 8 ohm, the third resistor, 1 over 10 ohm, that is the fourth resistor. So if you perform this summation, you will get 107 over 120. Then if I take reciprocals on both sides, that is, if 1 over R effective is equals to 107 over 120, therefore, if I take reciprocals on both sides, I'll have R effective over 1 being equal to the reciprocal of 1 over 7 divided by 120, which is just 1 over 20 over 1 over 7, which will give us 1.121 ohm. That is correct to 4 significant figures. Then lastly, we are required to find the current through the 8 ohm resistor. So because this is parallel connection, you have said that for any parallel connection, V total is equals to V1 is equals to V2 is equals to V3. Therefore, the total resistance, the total voltage through this particular circuit, which is the supply voltage 3 ohm, must be equal to the voltage through the 2 ohm resistor equals to voltage through the 6 ohm resistor is equals to voltage through the 8 and is equals to the voltage through the 10 ohm resistor. So for any parallel connection, V total is equals to V1 is equals to V2 is equals to V3. Therefore, V total is equals to voltage through the 2 ohm is equals to voltage through the 6 ohm, voltage through the 8 ohm, and voltage through the 10 ohm. So because we were given the supply voltage was 3 volts, it simply means if we want to find the current through the 8 ohm resistor, it means that we already have the voltage through the 3 ohm, that is the 8 ohm resistor. So the voltage through the 8 ohm resistor is equals to the supply voltage, which is 3 volts. Then from Ohm's law, V is equals to IR. Because we want to find the current, we'll simply make I to be the subject of the formula by dividing both sides by R. Therefore, I will be V over R. Therefore, the current through the 8 ohm is equals to voltage through the 8 ohm over resistance through the 8 ohm. So the voltage through the 8 ohm is equals to the supply voltage, simply because the resistors are connected in parallel, which is 3 volts divided by resistance through the 8 ohm is simply 8 ohm. So 3 divided by 8, you will get 0.375 amperes as the current through the 8 ohm resistor. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that never let the thought of failure stop you from pursuing your dreams. So the quote is warning us against allowing failure to be an obstacle to our future success. The quote is instead encouraging us to see failure as lessons that are very essential for our future success. Remember that excellence is never a straight path. You must go through and overcome some obstacles that will help you to build your mental strength in preparation for your success. And lastly, recall that every successful person has a painful story. Therefore, you should never give up while on your way to greatness. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll always get notified. Also, thank you very much for taking this channel to 5,000 subscribers. I do not take it for granted. I really appreciate. In case you know any student or anyone that you honestly think could benefit from this content, kindly refer them to Kind Tuition Academy. Thank you very much. Until next time, this is Kind Tuition Academy.